some evaluate problems at the beginning. Remember what these are actually asking you for. So this is your base, so it's saying 3 to what power equals 27? So this is another way of kind of wording that question. So 3 to what power is 27?
Minute 4.
Let's check. So remember, if you're not sure, there are always going to be problems that you can check on. They're never going to be kind of like weird numbers. I'm hearing 3 to the 3 cubed. Let's try 4 first.
It's
Nope.
nowhere near.
Well, it's not too off, but it's off. So 3 to the 3rd. Do you see how you can check though? You can try them and see which one's going to be right. So 3 to the 3rd. So my answer for this one is 3. So you're looking for an exponent as your answer. Go ahead. This one, the trick is to count the zeros. Now, you can only use this trick when your base is a 10 and this number is a 1 with a bunch of zeros. So when you have that sort of situation, the trick is count the zeros. How many zeros do I have? 9. So that's going to be your answer. And I can also go to my calculator like I did with the last one, and I can type it in, and I can double check it that way as well. All right, the next one says to use change of base. So this might be a formula you don't remember. So let's see what we've got. So if you think about it, and you think 3 to what power is 72, well, 3 to the 3rd was 27, so it's not 3, right? And 3 to the 4th was 81. So do you see how it's somewhere in between 3 and 4?
Oh, it's a decimal.
It's going to be a decimal. So this isn't a problem that I would have you do where you can just know it. Like, I'm not going to have you guess what decimal that is. So there's a formula that we can use to do it. So you're going to type in your log button. When you press your log button, do you remember what base it is always? 10, yeah. So that's your common logarithm. So this is called the change of base formula because we're going to change the base to 10, so it's something we can actually do on our calculator. So in the top and bottom of this fraction, we're going to change the base to base 10. Then you put what you were taking the logarithm of in the numerator, and you put your old base in the denominator. So this number goes here, and what you were taking the log of goes in the top. So on your calculator,
The bigger number goes on the top.
not the bigger number.
Alright,
The base number
Okay.
goes in the bottom, the bigger number goes in the top.
Alright, got you. Oh, so
Always,
it's
always. And then we always change it to base
Bro,
10.
it's just like how it looks. Like
Mhm.
you literally just like put a line through it.
Alright, on your calculator, let's figure this one out. You're going to press log. And do you see how there's no base? So we know it's a 10. Type in your 72,
Oh, yeah.
close it, and then I need my fraction bar, so that's the same as division. And then I'm going to press log again, and again it's always base 10.
Wait. No, keep going. Wait.
Okay, and then 3, because we're going to take the log of 3. So let me say how I typed it in. So I pressed my log button. Bless you. It automatically opened a parenthesis. So
Wait.
then I typed 7, 2.
Is
Yeah.
that dash a division sign?
Yeah, it sure is. Then I divided. Then I pressed my log button again. It automatically opens the parenthesis for you. And then I pressed 3. And then I closed it. So those were my keystrokes that I pressed. So I pressed log, it opened a parenthesis, I typed 72 and closed it, then I needed a fraction bar, which is the same as division, log 3. So if it helps you, you can write your keystrokes. Again, I'm not going to help you use your technology on the actual exam. So you need to know how to do this walking in.
So do we type log 372? What do we type? Like, what do we type for the answer?
You.
Just
Like-
look at you.
Oh, sorry. What do you get for the answer?
No,
Sorry.
I got the answer. No, I'm saying like, what do you, like, how do you write the full answer? Oh, it's just the answer. It's just that.
Just 3.89.
Oh, okay.
So that's how you would write your answer. Sorry,
Oh.
I realized I
thought we
didn't.
had to, like,
After
rewrite
all
it.
that discussion of how to do it, I never actually hit enter and got the. There it is. The answer is 3.89 because it is. Okay, 31. What do we need for this one? Desmos. Okay, now on Desmos, we've got kind of a chain here that we need to follow down. On Desmos, remember at the bottom there's that little like keyboard icon?
Mm-hmm.
You need to click on that. Then you need to click on the word functions. Remember this? And then you need to go to calculus is the kind of the topic, and it's log base A. So it looks like this. So this is the chain of things that you need to do.
Rated is on 0 undefined.
Yeah, it'll be undefined. We do have an asymptote. So go ahead and type it in. Your asymptote for these should always live at the same spot unless we shift it left or right. Okay, let me come around behind you, make sure you're getting a graph. So, no, you
Darn
need
it.
log base. You're close.
Alright, wait.
So you did the process correctly, but, you need to go down to log A. See how I wrote it up there? The one that says log base A, because that's the one that lets you type it in. That looks good, Leo. How are you doing? Go to the keyboard icon first. So follow the, and then functions, and then scroll until you see calculus. There you go. And then log base A. That looks good. Good. You have 2 logs for the price of 1. There you go. Yep, that's fine. Okay, 2 logs. Yes. Doubled up on the logarithms over there. Okay, so again, if you need to type or put this on your paper to remind you of next week, right, future you, how to do this problem, write it in there. Okay, so these are the points that I'm using. So I've got over 1/3 down at -1. I've got 1, 0, and I've got 3, 1. So this graph does have an asymptote. And it should look like this. How'd we do with the graph? Remember, you can click on it and find points. You can use different points than I use. Your graph shouldn't touch or cross the asymptote. So do you see how it never reaches 0? Okay. Because it's vertical, our asymptote is at x equals 0. So let's write that in first. So these always have a vertical asymptote. They'll never be y equals. They'll always be x equals. All right, the range is thinking up and down. So if I think up and down with this graph, is there anything off limits? Will it go down to negative infinity? Will it continue to go up to positive infinity? Okay, so my range is all real numbers. Now, let's think about the domain though. Do you see how there's no graph over here? Okay, so there's no graph until past 0. So my domain is going to be x's greater than 0. Don't put the equal to, because you see how it's never actually going to touch 0. It's just going to stay bigger than 0.